Hello students, in the previous video we have learned introduction and the meaning of transportation problem, network representation and as well as tabular representation of a transportation problem, and we have also learned in detail about the kinds of transportation problem which are the balanced and the unbalanced transportation problem. And moving on to the next topic, we have methods of obtaining initial feasible solution. In that we have first method, northwest corner method. So this northwest corner method is a very simple and efficient method to obtain an initial solution to a transportation problem. So this method is a direction oriented method. So by the name itself we can understand it is indicating northwest corner method. So by this we can understand it is a direction oriented method to allocate the units. So here you can observe this. So north, east, west and south. So always in this method the importance will be given to northwest corner cell of the tabular representation. Now let us understand clearly about the northwest corner method. So you can observe here, so northwest corner method, I have taken 4 destinations and 3 plants. I can also tell it as sources or factories, and here 4 destination I can also call them as warehouses. And you can observe the supply capacity of plant 1 is 6 units, supply capacity of plant 2 is 1 unit, and supply capacity of plant 3 is 10 units. And the demand requirement of destination 1 is 7 units, destination 2 is 5 units, destination 3 is 3 units and destination 4 is 2 units. Now before proceeding on to the problem, let us identify whether this particular problem is a balanced or unbalanced transportation problem. Now take the total of supply column, 6 plus 1 7 plus 10 17 and 7 plus 5 12, 12 plus 3 15 plus 2 17. So this problem is a balanced transportation problem. And now always in case of northwest corner method, allocation starts from the northwest corner cell. So when you observe the tabular representation, this particular row represents the north side direction and this side represents the west side. So always the allocation of units must start from the northwest corner cell. So here in this problem our northwest corner cell will be this. I am pointing towards it. So this is the northwest corner cell. So in case of northwest corner method, always the allocation should start from the northwest side. Now, so 2, 3, 11, 7, 1, 0, 6, 1, 5, 8, 15, 9. So all these numbers represent the cost of transporting a unit from different plants to different destinations. Now let us start the allocation. Before starting the allocation, first compare the supply and the demand. In case of destination 1, demand is 7 units, but the supply is only 6 units. So when there is a demand of 7 units and supply is of only 6 units, we cannot supply the whole demanded unit. So maximum we can supply only 6 units. So I have allocated 6 units to the first cell, and among the 6 units I have allocated 6 units. So how many units will be remaining? 0 units will be remaining. So I cannot allocate to the remaining cells. And in the same way, the demand was for 7 units and I have allocated 6 units. So how many units will be remaining? 1 unit. Okay, and next one, moving on to the next cell. So next northwest corner cell is this one. The supply is 1 unit and demand is also 1 unit. So I can easily allocate 1 unit. So among 1 unit I have allocated 1 unit. So for the remaining cells I cannot allocate because there is no sufficient supply. And here demand was 1 unit and 1 unit is allocated, so demand will reduce to 0 and there is no necessity to allocate for this cell. Moving on to the next cell, the demand is 5 units and supply is 10 units. So can I fulfill the demand? Yes, I can fulfill the demand of allocating 5 units. So here I am allocating 5 units. So from 10 units I have allocated 5 units, remaining are 5 units, and from the demanded units of 5 are allocated, so remaining is 0. Moving on to the next cell, demand is 3 units and supply is 5 units. So among the 5 units I can easily allocate 3 units. So how many units will be remaining after I have allocated 3 units? Only 2 units are remaining. So from the demand 3 units I have allocated, so demand will reduce to 0. And at the last, the remaining cell, we have 2 units of demand and 2 units of supply. So demand and supply are equal, so I can allocate 2 units wherein demand reduced to 0 and supply also reduced to 0. So this is how we allocate the units in case of northwest corner method. Yes, I repeat, first we have to identify the northwest corner cell and then compare the supply with the demand. As per the units of supply and demand, we have to allocate the units and go on reducing the units of demand and supply according to the problem. And at the last, so we have to find out the total cost of allocating the units from 3 plants to 4 destinations. Now 6 is representing units. I have allocated 6 units, and 2, as I have told earlier, 2 is a cost of transporting 1 unit and I have allocated 6 units. So 6 into 2 plus, and in the first row we did not allocate anything. Come to the second row, so I have allocated 1 unit at 1 rupee. So 1 unit at 1 rupee, and next, so in the second row only we have allocated to this cell, and coming back to the third row I have allocated 5 units of 8 rupees each. So 5 units of 8 rupees each, and next we have 3 units at 15 rupees each, and the next one 2 units at 9 rupees each. I have not taken this column because it is supply column and this row is demand column. We need to take only these 3 columns. So let us find out the total cost. So 6 into 2, 12 plus 1 plus 5 into 8, 40 plus 15 into 3, 45 plus 2 into 9, 18. So find out the total cost as per the allocated units and per unit cost. Now take the total. So it comes to 126 rupees. So this is the total cost that we have identified in case of northwest corner method. So in the notes which I have shared y'all, I have given some practice questions based on the northwest corner method. Do practice those questions, and if you have got any doubts you can ask me. And in the next video I'll go for least cost method.